So in chapter 13, problem 18, question says, draw the Fisher projection. That's where the vertical bonds mean you're going away and the horizontal bonds are implied to be coming out at you. And we have an example of that here, written on the left. Draw the Fisher projection for D-mannitol, produced when D-mannose is reduced. We have D-mannose here. The product of this is going to be D-mannitol, and the hint there that OL is telling us that that product is going to be an alcohol, so an OH. Now, a really key word here is the word reduced. Reduced means fewer bonds to oxygen. Now, right now, most of the molecule has as few bonds to oxygen as you possibly could. There's just one. Unless you kick the oxygen off, all the bonds to oxygen here are as small as they can be also. So this whole green part of the molecule is good as is. There's nothing we can really reduce there without kicking the OHs off the molecule. So what we're going to be interested in is this region right here. That's where we can make fewer bonds to oxygen, reduce the number of bonds to oxygen. And we can do that by erasing that one bond to oxygen, but now the carbon and the oxygen are missing a bond, so we can make a new bond to hydrogen. So you'd make this reaction, you might say, where's the hydrogen coming from? Well, you would put this molecule at the left in a container, you'd sprinkle it into a vat of water, and you'd bubble hydrogen gas through. And as it bubbles through, it would react and stick to the oxygen and the hydrogen. So, in this example, to reduce this sugar, this D-mannose, all we did was erase one of the bonds to oxygen, and both to oxygen and carbon add a bond to a hydrogen. The rest of the molecule stays exactly the same, and this is D-mannitol.